Hello and welcome to this episode. Okay, as you can see, we have been able to do the entire model. We've analyzed and we've done the design as well. So all we need to do now is I will show you how to display the design status. If you come under your display here, this is display tab. Just click on visual interrogation. Once you come here, if you scroll down, you will see design status. Once you click, it will pop up here. So whatever I click on, you will see it displayed by my left hand side. So I can move this menu in order for you to see what is going on here. So I would like to always leave it on design status. Okay, once I click on OK, you can see it's displaying here. Now the last thing we need to do is the foundation. If you come to your story 0, you have to double click on this ST0. Once you come here, it is important most times if you want to check the loading, the axial load from on the column. So if you click on visual interrogation, you can come to this column display here and you can click on this drop down menu. But you can see we have the axial load here. It can be checked. Whatever load you want to display, you can just check all of them here. If you also want the one for the bending moment and also for the one for the shear force. Okay, so if I click on this drop down, you will see several list of load combinations that are here that you can actually just check. So however, whichever load you want to display on the drawing, yes, you can just click on them, check them and click on OK. Once I click on OK on the story 0, you can see all of them are being displayed here. Okay, so you can see all the combination here. You can see the highest of it here is 258. That's the combination 1. This is 132. So from there you'll be able to know the most critical of them all. So by experience, I can be able to tell that either one of these two should be will most likely be the most critical of them all. Exactly, you can see this is 319.7. so this is most likely going to be the most critical, if I'm not mistaken. I don't think there will be any other column that will be carrying so much load as this one. So that being said, you can design any kind of foundation on ProtaStructure. Okay, so on this episode I will focus on the strip foundation. Then on the next one we'll talk about pad, and we'll talk about combined footing. Then we'll also go into the pile foundation, and then lastly our raft foundation. Okay, so to come up with your strip foundation, to come up with the strip foundation is very easy. All we need to do is to insert a beam here, and once we insert that ground beam, if you know the width of the beam and you know the depth that you want this beam to go, okay, all you need to do is to just the way you insert your normal ground floor beams is literally how you achieve this one as well. Okay, so you can just insert all the beams where you want them to be. Remember, I told you once you are able to insert your beams, you can come back to your review and the software will just do the magic and rearrange them properly as it should be. So it's very, very easy to actually manipulate the software. To use this software, it's very, very easy. Okay, so if these are all the areas we want this ground beam to be, for example, or let me take this here to be a point load. So this is what we are going to be having from the 3D. Okay, So if this is what we want, all I need to do is to select the beams and then right click on it. If I right click, I can click on insert strip footing. So if I click on insert strip footing, a menu will actually pop up for me. Exactly. So you can see this is the menu from here, but it's very important that before you do your foundation design, you should know the soil bearing capacity is very important, because and that soil bearing capacity is gotten from the soil reports. Okay, so the soil reports will be able to tell you the soil bearing capacity. I will always make emphasis on getting reinforced concrete design book by Victor O. Oyenuga. I will encourage you, if you are watching this video, to actually get that particular books. You can as well get it through me. It's very important. It helps you it gives you a lot of insight. It's a practical design book for engineers that are in practice. Okay, so that being said, all I need to do now is to just click on design. Once I click on design, and then I will click on OK. Once I click on OK, I'll click on OK, and you will see that footing displayed here. But as you can see, it has done some extension to our beams. If that is not what you want, you can as well edit it. So if I double click on it, I can come back and remove this cantilever and change it to 0. Remove the cantilever at the right hand side and change to 0. You can see the footing width is 1 meter. From here you can specify what the width of that your footing should be. You can as well specify the depth of that footing, and then you click on design. Once you click on design, you can as well check the design report. So you can see here it displays the moment and then the shear force. Okay, this is the shear force diagram, which is this is the shear force diagram. This is the bending moment diagram here. So once I click on OK, I think that report is generating the report. So you can see this is actually the footing report that has been generated by the software. You can convert it to a PDF or convert it to Microsoft Word. Probably maybe you want to do some little editing on it. Probably from here you probably want to change the calculation by, checked by, and all of that. Okay, but mind you, like I said, this is actually designed based on the soil bearing capacity by default that is on the system already. But it's important that you actually change and put in the actual soil bearing capacity that should be there. Okay, it's very important, because if you don't do that, it will design it and you may be having a very wrong specification of foundation, and which can lead to building collapse. Okay, so it's very important, and it's a very sensitive area that no one should ever joke with. Okay, so you can see that has been corrected here, although it's not displaying on the 3D. I will just close it and bring it back. But before then, it's important that when you come under your setting center here, or you can as well access this setting from this drop down. If you come to building setout, come to setting, a menu will pop up here. Click on setting center, it brings you back to your setting center here. You can come to this your foundation here and specify the soil bearing capacity. So you can see here, based on what I have here, is important. I can just change it to whatever I have on the site. So if by the soil report the value is 150, I can just type in that value there, and then when I come to my design, I will have to redesign the foundation all over again. So it's very important to specify all of that before designing your footing. You can as well delete the footing if you like. You can as well bring it back. So if I delete that footing, I can insert a beam again, and then so if I have 230 by 700 depth of beam, I will just insert it here. Sorry, I'll insert it here. It's not inserting. Okay, then I'll select it, select the beams, and select the beam and click on insert strip footing. So similarly, you do it for all of the beams that are here. You do similar for all the beams. So now we are now sure of our soil bearing capacity. Okay, we are now sure. We have specified the bearing capacity, so all I need to do is just to design it. So you can take out your time and specify. You can see footing bar size. You can change all of that. Maximum soil stress is what is considered on the selection of soil stress for calculating the footing width. Okay, so all of that. Footing eccentricity is 0. You can specify the eccentricity. So if I design it and I click on OK and I click on OK, and that is all. So similarly, I can do for all of them. So all you need to do is just to select the beams and right click and insert footing. Insert strip footing. Sorry. However, you can as well have a combined footing. Maybe you have a strip footing, you also have a pad footing. All of that can be achieved. Okay, so you can have a combined strip and pad footing all in your design. Okay, so however, it depends on how you want or whatever you want on your design. So similarly, if I want to insert my pad footing, all I need to do is just to click on the column and click on insert pad footing. Once I click on insert pad footing, a menu here will actually pop up for me. Once the menu pop up, you can see what I have. The depth of the footing, the width of the footing is 1200, 1400 by 1400. You discover that when you change that soil bearing capacity to a lower value, this footing and probably the depth may most likely actually change. Okay, so that is why it is important to actually do your soil report. It's very, very important. So if I click on OK, that is all. That column will be in, that footing will be inserted. So it is similar when you also want to do the combined footing. If you want to do your combined footing, all you need to do is to select the two columns that you want to insert a combined footing for and click on insert combined pad footing. So if I click on insert combined pad footing, a menu will actually pop up for me as well. Then from this menu you can see design is successful, so I can click on design as well again if I want to, and then I can come to pedestal. Sorry, let's come to rebar. Now this is one very sensitive area where a lot of people get it wrong. You can see for your combined footing, it is very important that you leave it as it is, so that you have a top reinforcement and also a bottom reinforcement. Okay, but for an isolated part, a single part, you don't need to have a top and bottom reinforcement, so that is going to be over designed, so there will be no need for that reinforcement there. So but so that's why for this one now it's important that you correct it. So if I double click on it to open this, I will come back to my rebar here. It's important to uncheck this top rebar. You understand? If you uncheck it, you will only be having a singly reinforced footing. You can see it's singly reinforced, the other one was doubly reinforced. So if I click on OK, now I have updated this footing. So that's basically all you need to do for all of them. Then in the next episode I will show you how to do the pile foundation. There we are going to be picking a soil report. From that soil report we will now be able to now design our pile foundation. Okay, from there we know that the pile capacity and all of that. So I will see you in the next episode. Okay.